and how it shapes our thinking and attitude for life. So you can ask me a question. I'll just give it a poll because many people just don't read the title and they just come in. So just okay, that's it. Hopefully this question will have some kind of uh, incentive for people to just go ahead and ask some question about science. So meanwhile, while we're waiting for people, what we can do is try to understand the question about why we only try to go and colonize the Mars. And the answer is simple and intuitive and practical. The thing is, all the other planets in our solar system, Mercury, Venus, okay, and other planets which are far away from us, are very difficult to reach. The planets which are closest to the sun are too hot, planets which are far away from us are too cold, and Mars is around a little bit of safe zone for us where we can send our planets, and hopefully when we go and live in the Mars we can we will be alive. So that's the basic question about it. But the real question is why in the world uh, we want to go and colonize the Mars, and what is our eventual goal plan. And the thing is, it all starts or rather is about the curiosity of humans. Long back when we used to live in the caves and we were just literally monkeys jumping around and eating berries, and that could be our life. But what we did, we started exploring and we started going from one place to another unknown what the world entails. We swam and got to another island and we experimented, and because of that exploration and experimentation, hi Sophia, welcome to the chat. Because of the exploration and the curiosity of the human mind, we are here in this 21st century. And now suddenly do you want us to stop exploring and being curious? That is the reason. The curiosity and the exploration of the human minds has brought us here in this 21st century with all the tools and with the amazing things you have technological wise. That is the reason we keep on exploring the solar system, colonization of Mars, going to moon, and all the robotic missions. We keep on doing this for a very simple reason, because it keeps us curious and keeps us exploration. And there might be not benefits in the short run, but there are benefits definitely in the long run. One of the benefits is a side product, because going to the space and is a very difficult task. Okay, this seems like a very spam comment, but okay. Hello Martin, welcome to the chat. When we go to the space, it's a very difficult question, difficult hard problem, and because of that we need to solve many hard questions along the way. For example, in space there is cold, there is less pressure, sound travel is difficult, we need to make suits which can make humans survive, so on and so forth. And because of this we invent many things, we experiment many things, and because of this there are many products which are side product of the space exploration and which can be used back on earth. So that's a very simple benefit of going to the space exploration. But there is another thing. Imagine the biggest problem which we face in the 21st century is about climate change. The minerals we are running out of, we are trying to catch on the solar, the sun, because it will be there for millions and billions of years. Okay, that's what's the definition of mathematics? That's a very interesting question, Sir, I'll just get back to you. Just let me complete my train of thought about why we keep exploring. Uh, the the thing is, imagine the climate change problem. There are We are always concerned about why the minerals and solar things will get vanish in our earth, and we are just strangling and trying to survive it. Now imagine if we were able to go and colonize Mars. We can harness the minerals of uh, that planet, even if not that planet, of anything which is there, asteroids and so on, in the celestial body. It will be in addition to the Earth, and because if you keep exploring, we will incrementally move forward, and then there will be no shortage of any minerals, and then you don't have to worry about climate change, because we would have a solution of the climate change in the form of new technological advancement. So that's why space exploration is very important. Now here's a very interesting question: what's the definition of mathematics? And uh, to give you a definition, I'll just start by a very cryptic thing. Let's say you're on a space exploration and you find aliens, okay, celestial body, intelligent body. What language would they speak? They might not speak English, German, French, anything. Maybe the things which we called in physics the gravity and all, they will have a different word for it. But the mathematical language will be the same or analogous. It might not be the same equations like a plus b is equal to whole square. There will be some another notation, but it will still be something plus something the whole square. The mathematical languages prevails in the universe, because mathematics is the language of the universe. Okay, so we have the universe around us, and what we discover, what we observe, and what we note down is called physics. Okay, but to understand the physics, to give the to what I have absorbed, to make it in a concrete writing and make it understand to another being, the language which we use, it's called mathematics, and that mathematics language is a universal language. So in an essence, mathematics is a superior thing for than science, because you can observe science, you can understand science, you can learn science, but to communicate on a deeper level, or to understand it more clearly with more clarity, you need mathematics. So that's your that's that's a definition of mathematics for you, sir. Now if you observe the whole universe, and uh, you might see that, okay, once you set up an equation in physics, true, that is also true. That's what I'm saying. Like, what is physics? Physics or science is an experiment. You see something, you hypothesis something, like, so if you take something and you leave it, it falls. Okay, then you do an experiment, okay, and you make a conclusion and you make a repeatable experiment. But to put all of your thought into paper, to make it understandable, to make someone understand, or make yourself even understand, you need the help of mathematics language. And mathematics language might seem like you're taking things out of thin air. No, it's not that. It's You are taking what is already in the universe, and you're just interpreting it in the language we have created. Okay, but the equations and all are all universal language. Okay. Hmm. So there you go. If you need to understand the aliens when they come, you better know your mathematics. Our solar system, our sun, is a very big thing. Okay, it, there are nuclear reactions going on every second, and it will still not explode or implode within the next hundreds of millions of years. The sun is so huge, but when you compare the sun to the whole of universe, it's still nothing. Okay, so in essence, like, if you see the exploration of a human being. We are only explored till moon, and we have sent the robots till Mars. Of course, there are voyages which we have sent far away. Hello Glacier, how are you? I'm very fine. How are you doing, sir? You have any question? You may please share and we can have a chat. Uh, but the extent to which the humans have explored is very limited in distance. So, despite it seemed like a too much uh, okay, that's an interesting question. uh, Despite our length and breadth of the exploration, we are still only scratching the surface. Now there's an interesting question here: is every quantity in physics redefined in terms of just energy except for time and distance? Now let me uh, it's not that everything is kind of interchangeable with each other. Okay, and even if it is not interchangeable, it can be expressed, and even if it can't be expressed, it can be manipulated with each other. For example, let's take the example of uh, energy, force. Okay, you put force into something, force is called mass into acceleration. Okay, but mass is energy, so there is energy in force, but there is energy in pressure also. Anywhere where you have an heat as a byproduct, there is energy. But let's see something about time and distance. Now time is a very tricky thing. Like, what is time? How do you even define time? There are various ways to define time. Let me give you a very short thought experiment. One way to define time is by the change. For example, you you're at a you have cells in your body. Okay, and tomorrow the number of cells reduces because of aging. So you can say at some time has passed, and the cells will keep reducing and then keep damaging and keep changing, and you will say some time has passed. And that is the way the time is measured, really. Because if nothing changes, there is no way to measure time. Let's imagine a ball, and you're only an observer, and there is darkness, and there is nothing as just one ball. But the ball has a property, it doesn't changes. You close your eyes, you open your eyes after like a million years, but the ball is the same. How do you know how much time has passed? There is no relationship, there is no equation to find out how much time has passed. So, in an essence, even if a million years have passed, but there is nothing change, there is no way to measure time. So, time can only be measured when there is change. Now, let's extrapolate it to the universe level. Universe started with a big bang, and there was a tiny dot with a huge ball of energy. Then big bang happened, and everything is happening. We are in that universe. It is expanding, and so on and so forth. And with that expansion, we are seeing the distances. With the distances, we have speed. We have a relation between time and speed, and at time slows down, so on and so forth. Theory of relativity. All of the beautiful things are happening. But let's imagine, after a billion years, everything just collapses again into a single point. Now, from the point of view of an observer or the universe, it started as a dot and ended on a dot. If the universe closes its eye in the journey and open it, how did it know how much time has passed? Or has the time ever passed? Or the time does exist. But whatever is happening in the between, it's like nothing is happening. So that's a very beautiful thought process for you to ponder about time and distance and energy. All of it is there and nothing is there when either displacement zero for universe of Saturn. True. If the starting and the end point are the same, has the time really passed? We never know. How can you quantify it? Universe is a mystery, time is a mystery. We human beings, because we are a matter of very less speed, we are trapped in time. Because when you consider it from the angle of a photon which is moving at speed of light, the starting and ending are the same, because there is no distance for photon. The photon can travel the whole of universe in an instant, and there is no concept of distance nor a concept of time for photon. So we are living in a universe where for some things there is no distance of time, and for us the time doesn't pass. Fascinating, isn't it? Universe is a mystery. The solar system is everything is a mystery, because there is some rules here and there, and we are just observing. We are just an observer and noter of the things. We are not making these rules. We don't know who is making these rules, why such rules exist. We are just an observer, and we are just living plain in this universe. Okay, that's it for today, guys. See you next time.